Today we're going to talk about pedigrees, which is a way of tracking traits through a family and looking at the different generations and how they express traits. It's easy to study genetics of fruit flies or pea plants because the generation time is so short and because you can mate any individuals you choose. Humans are harder to study, so we use pedigrees as one tool for studying the family history of a genetic condition. So what is a pedigree chart? A pedigree chart shows a record of the family of an individual. They can be used to study the transmission of hereditary conditions, and they are particularly useful when there are large families and a good family record over several generations. The goals of pedigree analysis are 1. To determine the mode of inheritance. Is the trait that we're tracking dominant, recessive, or partially dominant? In other words, incomplete dominance or codominance. Is it sex-linked or autosomal? Do I see it as often in males as females, or does sex not matter? 2. To determine the probability of an affected offspring for a given cross. Studying human genetics. Today, genetic engineering has new tools to offer doctors studying genetic diseases. A genetic counselor will still use pedigree charts, however, to help determine the distribution of a disease in an affected family. So there are some symbols, and I believe you need to write these down in your notes as I did not put them in there for you. If I have a square that is not shaded, in other words, it's clear, it's considered a normal male, a male who is not possessing the trait. If the square is shaded, then we say that the male is affective. It does not mean that the disease, it doesn't tell me if the disease is dominant or recessive. It only tells me whether or not the person is showing the trait. If I have a circle, it means it's female, and if it's not shaded, it means it's a normal female, a female who's not showing the trait. And if it is shaded, it means that the female is affected or showing the trait. When there is a line between a circle and a square, it means that there has been a marriage. Some more symbols. We show a marriage as a line between a circle and a square. If there is something that we call consanguineous mating, in other words, incest in a way, a cousin marries a cousin or an aunt marries a cousin, we show it with a double line. Although this is not super common in the ones that we'll look at, it is there and could show up on SOL, therefore you should be familiar with it. To show offspring, we show a vertical line, and from that vertical line, if there's a single offspring, you would have your circle or your square. If not, you will see a horizontal line connecting the two individuals. This does not mean that these two individuals are married, it means that they're a brother and sister. When I organize my pedigree chart, the pedigree chart in this particular case is showing 20 individuals. Each of these Roman numerals on the side are showing me the generation of the family. So Roman numeral 1 tells me that individual 1 and individual 2 are of the first generation. Individuals in each generation are identified by Arabic numerals, meaning the numbers that you're used to seeing. And they're numbered from the left to the right. Therefore, the affected individuals are generation 2, individual 3. So I look at Roman numeral 2 and count over 1, 2, 3 spaces. Generation 4, individuals 2 and 3. This particular one shows a marriage that resulted in 5 children. There are 2 daughters, the oldest and the youngest, and 3 sons, all of which fall in the middle. The eldest son is affected by the condition, which is not actually a true statement. The middle son is affected by the condition. Types of traits studied using pedigrees. We can study autosomal traits or sex-linked traits. We can study dominant traits or recessive traits. Pretty much we can study just about any type of disease or trait that we want to using this method. So what type of pedigree is this, and what's your proof? So we're trying to figure out, is it dominant or recessive? Is it sex-linked or autosomal, meaning not related to a sex chromosome? In this particular case, we notice that males and females are both afflicted, meaning that more than likely it is an autosomal trait, and it does not skip any generations, meaning that more than likely it's dominant. So it's dominant because 5 and 6 have an unaffected child, meaning that they're both affected, but they do not have an affected child. In other words, they're both heterozygous and have produced a child who is homozygous recessive. It's autosomal because both genders get it pretty evenly. Autosomal dominant pedigrees have some common things that you're going to see. You're going to see that the trait is common in the pedigree and therefore many individuals are affected, that the trait is found in every generation, and that affected individuals can transmit the trait to approximately half of their children, regardless of their sex. Autosomal dominant traits. There are a few autosomal dominant human diseases, but some rare traits have this inheritance pattern. For example, achondroplasia, which is a skeletal disorder causing dwarfism, is a trait that is actually autosomal dominant. In this one, we're trying to figure out, is it autosomal, or is it sex-linked? Is it recessive, or is it dominant? It is recessive because the trait skips generations, and 2 affected people have 4 kids with the trait. It's autosomal because both genders get it in pretty even numbers. Cystic fibrosis is an example of an autosomal recessive trait. There are some autosomal recessive diseases in humans, primarily cystic fibrosis, where a child has trouble breathing due to an increased level of mucus in their lungs. Sickle cell anemia, where the cell is misshapen instead of being donut-shaped, it's more of a C-shaped and therefore cannot carry as much oxygen around the body. PKU, which is another type of autosomal recessive trait, and Tay-Sachs disease, which Tay-Sachs oftentimes is going to afflict females more often than males. However, it is not linked to an X chromosome. Again, we're going to keep on doing this and try and figure out, is it autosomal or sex-linked? Is it dominant or recessive? Notice that fathers pass the trait on to all of the daughters, but none of their sons. So I have a father, individual 1 of generation 1, has passed it on to individual 2, 4, and 8 of generation 2. Individual 7 of generation 3 has passed it on to individual 4 and 6 of generation 4. Mothers pass the trait on to sons and daughters. So if we take a look at individual 2 of generation 2, they passed it on to individual 2 of generation 3, who's a son, and individual 3 of generation 3, who is a daughter. In this case, we would say it's an X-linked dominant or sex-linked dominant trait, meaning that the father automatically passes it to the daughter, and a mother will pass it to both sons and daughters. What type of pedigree is this, and why do you think so? Affected moms have affected sons, and half circles represent carriers, in other words, heterozygous individuals. Individuals who carry the trait, in other words, they don't express it but could pass it on to offspring. Affected dads have unaffected sons and carrier daughters. The half circle, again, represents the carriers. So females express it only if they get a copy from both parents. And it's expressed in males if present. That tells me that it is a sex-linked trait and it's recessive. Hemophilia is an example of an X-linked recessive disease. So if a male is affected with hemophilia, he received the trait from his mother, and his mother is either afflicted, in other words, has it, or is a carrier. This is a disease that was traced in the royal family and is actually fairly common in their lineage. And the pedigree that you're looking at right now is the pedigree of the royal family. What type of pedigree is this, and why do you think so? In this particular pedigree, notice that only males get the disease. There is not a single female on the pedigree who is affected by the disease. In this case, it must be Y-linked since there are no females who are affected by this particular trait.